so find the decimal form of 15/8. Okay, do you remember how we find the decimal if we are given a fraction? Anybody remember that?
Divide the denominator by the numerator?
Actually, it's the numerator divided by the denominator. You may have thought that and just said it wrong. It's top divided by bottom. So we're going to take the top number and divide it by the bottom number. Going to do some good old-fashioned long division. So remember when we do that, we put a couple of zeros on here. Right? Now 8 goes into 15 once. We'll subtract. Now, did you remember to put a decimal point and some zeros? Okay. So now 8 goes into 70.
6. No. 9.
I think 8.
8.
Because 8 times 8 is 64. Oh, we gotta get the cobwebs out, right? And then we'll subtract. 8 goes into 60.
7 times.
7 times, that's good. And subtract. Oh, finally, it ends, right? 1.875.
Yes.
That's called a terminating decimal. It took us a while, but it eventually stopped. Top divided by bottom. So when I look at the next one, negative 11/6, I'm going to divide 11 by 6. Always top divided by bottom.
Can I get it in the morning? Yeah.
All right, you have this one done while I'm messing around here? Notice I'm not worried about the negative right now. I know my answer is going to end up being negative. So 6 goes into 50 8 times. And that's a 3. Uh-oh. What's going to happen? The 3 is going to repeat. How do I write that? A little bar over the top. So negative 1.83 with a little bar over the top. That's called a repeating decimal, right? So we have an example of a terminating decimal and a repeating decimal. Yes, it's negative. Negative 1.83. Yep. Okay. Now we're going to do a little graphing on the number line. Okay. So x is greater than 3. First of all, did you all recognize that's a greater than symbol? It's a greater than. What does that look like on the number line?
Open circle.
It's open circle. Open circle at the 3, right? And by the way, you don't have to put all the numbers on the number line. Just put the one you want. I mean, if you want to put more, that's fine. But we really only care about the 3. And that's an open circle because there's no or equal to. And it's shaded greater than, so it's shaded that way. Very nicely done. All the numbers bigger than 3. All right, what about the next one? What does this look like? Now, first of all, you're going to have 2 numbers on the number line.
-4, open circle.
right? We're going to have two numbers on the number line because there's two numbers in the problem. Are we going to use open dots or closed dots? Well, the negative 4 is going to be open and the 2 is going to be closed because of the signs, right? And then where am I going to shade?
Opposite direction.
Let's do it to the left and the negative 4 to the right.
See this X right here? See how he's sitting right in between the negative 4 and the 2? Since he's sitting in between the negative 4 and the 2, we're going to shade in between the negative 4 and the 2. Now, here comes something that you may not have talked about last year. This does not represent an ordered pair. In other words, you're not going to go left 1 and up 3. That's not what this means, even though it looks like that. This is the interval of numbers from negative 1 to 3 and everything in between. This is what we call interval notation. And the parentheses indicate open dots. So there's an open dot at negative 1, there's an open dot at 3, and we're going to shade everything in between. So this actually means the same as this. Those mean exactly the same thing. When you take your calculus class, this is how you'll write all of your inequalities. You won't use this notation anymore. This is the notation you use when you do math. So the parentheses tell me they're open dots. Now look at the next one. What is different about this one? It has a bracket. Now, if the parentheses mean open dots, you want to take any guess what a bracket means? Closed dot. So you're going to have a closed dot at negative 2, an open dot at 6 because it has a parentheses. Parentheses are open, brackets are closed. And then we shade everything in between. It's real easy. You just got to remember the rule. Bracket is closed, parentheses is open. Oh my goodness, what is this?
Negative.
This is a negative infinity, right? You've all seen the infinity symbol before?
Yeah.
Okay, and negative infinity means this way, right? Out here is negative infinity and out here is positive infinity, right on the number line? Any idea what's happening in this problem?
The 4 is closed.
The 4 is closed, so I got a closed dot at 4.
Open at negative infinity.
Now, let's talk about that, Mary Kate. Can I ever get to negative infinity? Can I put a dot there? No. How would I indicate that I'm going to negative infinity? I can't put a dot there, but what can I do? Shade it in, including the arrow, right? So that's what this is going to look like. This is going to be all of this. There's no dot. You can't put a dot at negative infinity because you can't get there. But you can indicate you're going there by shading in the arrow. Does that make sense to you? All right. Now, number 3. Now we're going to write as an inequality. Now, this is what we mean by an inequality with the less than or greater than symbols, okay? That's what we mean by an inequality. So, any ideas? You want to take a wild guess? What's that going to look like? Mary Kate?
4 less than x greater than 6.
Actually, you're so close. You're so close. Thank you. When you put an x between two numbers, which is exactly what this is talking about. The symbols are always less than. Always less than. Never put a greater than in an expression like that. They're always less than. How come these don't have or equal to? Because they're not brackets, right? Right? If they're brackets, they're or equal to. If they're parentheses, they're just plain. Nicely done. All right, how about this one? What's that gonna look like?
6 is less than equal to X is less than 20.
Now, do I ever put an infinity in an equation or an inequality?
No.
What is he saying
Oh,
here?
wait, wouldn't it be closed?
So let's graph it. If we graphed it, we'd have a closed dot at 6, and then we would shade it this way. Okay, so what does that look like in terms of an inequality? X isn't between two numbers. It's just X is greater than or equal to 6. There's only one number. So X is greater than or equal to 6. Yes, ma'am?
Why would it be greater than or equal to?
Because this is a bracket. And whenever you have a bracket, it's going to be an or equal to. All right, what's this one look like? This is a picture. What inequality is that going to be? Any idea?
Negative 1 is less than x less than 5.
Less than or equal to
5.
5? So why is the negative 1 a less than? Open. Why is the 5 a less than or equal to? Close. If we wrote it as an interval, it would look like this, right? All of these are exactly the same thing, just different ways of writing them. All right. Interval. Interval, remember, means the parentheses and the brackets. That's what interval notation means. This is interval notation. So what would this one look like as an interval?
Parentheses.
4,
9 parentheses.
Bingo. First number, comma, last number. And this one has parentheses because there is no or equal to. What about this one?
Bracket, -3, comma, parentheses.
Perfect. Perfect. Bracket, -3, comma, parentheses. Perfect. You put your two numbers in there. Little big, little comma big. And then if it's or equal to, it gets a bracket. If it's not or equal to, it gets a parentheses. Here comes the hard one. This one's going to have an infinity in it. I don't know who said that, but you're getting the hang of this. If there are two numbers, it's number, comma, number. If there's only one number, you're going to have to use an infinity. Because if there's only one number, you shaded the number line, right?
Does that mean both sides of brackets?
Actually, Ella, great question. Clearly, the 2 is going to be bracketed. But infinities are never bracketed. Infinities are always parentheses. Can anybody explain that? Why would infinities be parentheses? David? You never get there. You can't color in that dot, right? So infinity will always, always, always be open. The 2 is closed because bracketed because of the closed dot, but the infinity is always open. Did you make a little note there along the side? Infinity always parentheses, always. Anytime you use an infinity, you're going to be using parentheses. Okay, does anybody have a question about that? Okay, additive inverse. Another word for the additive inverse is opposite. So where I wrote additive inverse, right above that, write opposite. And what would be the opposite of this number? Can you take a guess? It would be positive 3 and negative 5. Because what happens, this is the answer, what happens if you add those together? They cancel, you get 0. Opposites cancel each other out. What's the opposite or the additive inverse of 16? Negative 16. You people are on fire. Awesome. Number 6. Use the distributive property. Love that. You all know what the distributive property is. You've done it for many, many years. Anybody want to venture an answer? Mr. Strauss?
Well, that's 2 plus 6
So we'll say 12x squared plus 6xy. Nicely done, Jaden. That's perfect. Does everybody remember the distributive property is the one where you when you were little, you do arrows like this to remind yourself? And when we multiply an x times an x, we get an x squared. That's how we got that. Now, the next one is the reverse. Very good. The distributive property works both ways. You can put the number in, but you can also pull it out. So what could come out of both of these terms? An x. And if we took out an x, what would we have left? A 5x. There's 2 of them here. Minus 8y.
Yep.
And of course you can check yourself, because if you multiplied this back in, you should end up with this again, right? All right, try C. Try C on your own. Tell me what you get. Don't say it out loud yet. Let everybody have a chance. Katie, you got an idea?
I took out the 2. Like, I turned the exponent and then.
So you took out an a to the second?
Yeah.
Yep, perfect. There's 3 a's here and 2 a's here. So we're going to take out 2 of them. Did you take out anything else?
Z.
A z, perfect. Now be careful, you guys. If you take out an a squared and a z, all you'll have left is that leftover a. Because you're taking out 2 of them and you have 3 of them. So you're going to have 1 left over. And then, wait, you took out both of the a's. There's no a's. Took out 1 z. So there'll be 4 left? How many of you got that on your own? Good job. Good job. If you didn't get that, are you okay with that explanation? Does that make sense to you? All right, what about D? What are we going to have for D? Antoine, you got an idea for D? 10x to the third. Nicely done. Minus what? 6x squared y. Yep, that's perfect. So 10x to the third minus 6x squared y.
For the next one, do you take numbers out?
Yep, for the next one, all you can take out are numbers. So you want to find the biggest number that you can take out. Does 32 go into 160?
5 times.
5 times. So we can actually take out a 32. Now you could take out other things like an 8 or a 4 or a 2, but you got to take out the biggest thing that you can. So the biggest we can take out is 32. And that will leave us with 5a minus b. Because 32 times 5 is 160. All right, do F. Watch that sign in there. Watch that negative. Let's see. Who have I not heard from today? Caroline? Take a guess at F. What do you think? Yep. It would be positive because you're taking a negative times a negative. Yep. Have confidence, you got it. So she says negative 6x plus 21y. Did everybody catch the positive in there like she did? It's a negative times a negative. All good? Okay. All right, now this next section looks a little crazy. We're simplifying.
Number 7.
Yeah. So now we're ready to start part 7. And we're going to simplify all of these x's and y's. All righty. Now this problem looks very hard, but it isn't. You're just going to cancel some things out. So on the top, we have 3 x's, and on the bottom, we have 2 x's. So they will cancel and leave me with an extra x. Where? On the top or the bottom? The top, because that's who has more. The top has more than the bottom, so we're going to have an x on the top. If you're confused by that, think about x cubed over x squared. If you multiplied, and if you wrote it out longhand, see how these cancel? And you're left with 1 extra 1 on the top. Now, what about the y's? We got 4 on the top and 5 on the bottom. So there's an extra y on the bottom. Whoever has the most gets the extras. So that reduces to just x over y. Trey, you with me? Okay. All right, oh boy. Oh boy, this makes you dig back in your memories. Ay, 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 ay. Anybody anybody have any recollection at all? Jaden?
Well, you're gonna have to move the x and the y up. You can't have negative exponent.
Okay, stop right there. I love it. Say that one more time. You can't
Have negative exponent.
have a negative exponent. Can't have a negative exponent. So you flip it. Very good. You people are awesome today. If you're this good on a Monday, I can't wait to see what you're like later in the week. This is awesome. So the negative exponent flips the fraction. If you've forgotten that, make a little note to the side. The negative exponent flips the fraction. Okay. Now, when you have a parentheses to a power, everything in the parentheses gets the power. So this is going to become an x to the second. This is going to become a y to the second. And what about the bottom? 9. Very good. So there's your answer. X squared, y squared over 9. Perfect. All right. Let's see. Eli, you got an idea on how we might start this?
Distribute the 2.
Perfect. We're going to apply this 2 to everything in the parentheses, including the 4 now, okay? So we have 4 squared, 16. What about x squared squared? What's that? X to the 4th. So we don't have to do anything to anything else. We take care of that first. Like Eli said, very nicely done. Now, can the 16 and the 4 cancel? What will that leave me with? A 4 on the top, right? So that's taken care of. Now I got an x to the 4th over an x squared. So we leave me with 2 extras on the top. And I guess y to the 5th. And I don't really need that line because I don't have anything in the bottom anymore. It's just 4x squared y to the 5th. Now you need to ask if you got a question about that. Oh my goodness. Look at this. Now this is a little bit different than this one. This one, the whole shebang was to a negative power. Here, just bits and pieces of it are to a negative power. So I'm not going to flip the whole thing. I only flip the whole thing if the whole thing has the negative. What do I do when only pieces of it are negative? Clara? Exactly. So I don't know if you could hear or not. What she said was, you just move the ones that have the negative exponents. So, see this guy right here? He's going to come down to the bottom. He comes down to the bottom. That comes down to the bottom. Now what about this Z right here? What do I do with him? He stays right where he's at. Now what about this x to the 4th? Is that going to go up? No, that's going to stay put because it's not negative. You only move the ones is e to the sixth. Stays down. If you have a negative exponent, you move. If you don't have a negative exponent, you don't move. All right, so here we go. I'm just going to leave the top alone. Now look on the bottom. What do we have right here? X to the what? 6. Nice. We have 4 of them and 2 of them. Now, does anything cancel? The y, some of the y's will cancel. So let's see. We got 5 of them and 3 of them. So y2 on top. Uh-oh. We got 1z over 6 z's. Z5 on the bottom. And x6 just stays on the bottom. That's a tricky problem. Look at all that work. Anybody have a question about any of those steps? Some of you can do that in your head, and that's fine. You do not have to show every single step if you don't want to. All right, E. What's happening with E? What's going to be on the top?
X squared.
Well, it's x squared, but then it's to the 3rd power, so it's like x squared, x squared, x squared, which is going to make x to the 6th.
Oh.
When you get, if you get confused, remember cubing means multiplying times itself 3 times. So you have 2 of them, 2 of them, 2 of them. Isn't that going to make 6 of them? Yeah, it is. Over, watch this. Exactly. 3 cubed is 27. And you just keep it that way. Nothing cancels. You can't cancel 6 into 27. That's an exponent. So it's just x to the 6th over 27, because 3 times 3 times 3. All right? See if you can do that last problem. Yes. No, okay, let's just hang on for a few minutes.
You almost can't have like exponents for a second, right? Or is it the whole number?
Couldn't hear you. What did you say, Kevin?
Like the exponent is the only thing that can't be negative.
Yes. The exponent is what can't be negative. So the first thing you're going to do, I hope, is flip that. So did you flip it over and make it x over 2 squared?
No, I didn't.
That's what you want to do. You want to flip it over. Flip it over. And then square everything. So what'd you end up with, Miriam? X squared over 4 is what Miriam got. I agree with her. That's the right answer. Those are hard. Some of those are hard. Anyone have a question about that? Okay. Next section, section 8, is about scientific notation. Do you remember what scientific notation looks like?
Does it look 10 times x?
Yeah, it's the one where you have something times 10 to a power. Right? Zane, you doing okay? Okay. think back to your chemistry experience. You all took chemistry, right? I think everybody takes chemistry.
Yeah. You did a lot of this.
So you did a lot of this. You took this decimal point right here and you moved it 1, 2, 3, 4, 5 places. And what did you do with the 5? You moved it 5 places. So that became the exponent, right? Because the exponent is the number of places you move that decimal. And then this number here was 3.14683. Because the rule for scientific notation is you have to move the decimal point till it's after, just right after the first number. This one's a little bit trickier. David? 10 to the negative what? 1? Did you say 1? I couldn't hear you. Okay, it's 10 to the negative first because, David, we need to move this decimal point 1 place. Because the rule for scientific notation is your number, like this number right here, has to be between 1 and 10. So you can only have one number in front of the decimal. So you're going to move it 1 place. So you have 7.136. But since this number is tiny, its exponent has to be negative. The rule actually says if you move the decimal point to the right, you're going to have a negative exponent. I can never remember that rule, so I just remember if it's a small number, the exponent's negative. If it's a big number, the exponent is positive. 7 point. The number has to be between 1 and 10 when you write this in scientific notation. All right, we're going to do a couple more. Here we go. Number 9. Oh my. I need some help with a calculator here. Who's got a calculator? I do. By the way, we will need a graphing calculator, but you can check them out from the library, or you can get your own. You were supposed to have one last year, so hopefully you have one already, but if you don't, you need to get one. You don't need it for this. What's 3.16 times 1.43? So what I'm going to do, guys, is I'm going to multiply this times this and divide by this. So someone with a calculator, 3.16 times 1.43 divided by 1.23. So what is it? 3.6738. And maybe some more after that, even, but we'll stop there.
Wait, can you restate that?
Yep. We multiply, these two are being multiplied. And then that one is being divided. So I'm not worried about the tens. I'm just doing the number part. So I multiply these two together. And then divide by this. And then this was a big, huge thing. We rounded it off. Okay? Now I got to deal with the 10 part. So I got a 5 and a negative 8. So this is like having 5 tens and negative 8 tens. What does that make? Negative 3? So I have 10 to the negative third over 10 to the negative 10th. Don't freak out. This would go to the bottom, right? and that would go to the top. So we have 10 tens on the top and 3 tens on the bottom. Some of those will cancel and leave me with 7 tens. Perfect. So one more time, let's go through the 10 part. Looking just at the 10s. So we have 5 of them. So if we look at it like a fraction, we have 5 of them on the top, 8 of them on the bottom, and 10 of them on the top. So that's 15 over 8. That's a little different than the first way I did it, but it doesn't matter. We still get 7. 15 minus 8. Yes, Caroline? Yes, yes. Yep. Yep. What? No, we're leaving it in scientific notation. If we wanted to write the decimal form of this, we'd move it and all that stuff, but we're just leaving it like that. All right, let's look at the next one. Come on now, stay focused. This one looks a little easier. Okay? Now, how did we do the last one? Let's do this one the same way. We're going to multiply the numbers. Okay, so you guys with calculators. 19.096. Now this is a little easier. We got 10 tens and we've got 13 tens. So what's that give me altogether? 23 tens. No negatives to mess with. No division. It's all multiplication. So we're just adding those exponents. 10 tens and 13 tens. Now, is there anybody who's got a problem with that answer? Because I do. We didn't make any mistakes, but we are not done.
Oh, the one.
Exactly. We didn't make any mistakes. We did it exactly right. But can we have a number that looks like this? Doesn't that have to be 1.9096? Now listen carefully. When I move the decimal point, it's going to change my exponent. Right? Now listen. Did I make this number bigger or smaller? I made it smaller. And if I made this part smaller, the exponent has got to get bigger. In order to keep the number the same, if I make part of it smaller, I have to make the other part bigger. If I made both parts smaller, I'd end up with a smaller number. So if I make one part smaller, I gotta make the other part bigger. If I make one part bigger, I gotta make the other part smaller. Does that make sense? Sort of. I know we need to practice some more, but okay. All right. Quickly, let's run through the properties and then we'll be done with this section. What property is A? 10A. Distributive. Everybody gets that one right. Nobody misses distributive. Now, B is not distributive. B is not distributive. What is B? Commutative. Oh my gosh, you're awesome. I'll write that up here in case you forgot how to spell it. B is the commutative property. Because the commutative property switches the order. And isn't that what happened in problem B? The order change. How about C? It is commutative. Boys and girls, I just said, if the order changes, it's commutative. Isn't that what happened in this problem? Didn't the order change? Nope. If the order of the operation changes. What's B? It is the identity. Very good. It's the additive identity.
The next one is communicating.
Okay, now be careful. For the next one, E. Did the order change? No. E is associative.
I always think that was
Yeah, you just got to remember commutative is order.
the one problem.
Guys, come on, we got to get this done.
Multiplication identity.
Yep, multiplicative identity. Very good.
Division identity.
No, there is no division identity. It's called the multiplicative inverse. All right, one more.
And then,
With a distributive, yep. Good job. Now, in Schoology, I put an extra property practice sheet with answers. So if you're a little fuzzy on your properties, feel free to look up that extra practice sheet and work on that. We just finished P1, so your P1 homework will be due on Wednesday.
Where's the homework?
Remember, I gave you the packet, but it's also and that, kids, that's only the first page. The first page of homework is due on Wednesday, right? Here comes our COVID killer.
how would I get to the last one?
If you need practice, feel free to do that. Property worksheet.
And I was looked down at my notes and I was like, what's big anything? What did I
Are you in the Lewis's period for theology?
Did you get that? Do we have? We don't have it today, right?
No.
But we got the email
About it being like
outside.
outside.
Yeah.
Is it also in the lab?
Yeah, I just looked and it says we're in the lab now.
Yeah. So, do we just like?
I bet we just like play it by like whatever she says.
Yeah. So we walk all the way around. Yeah, because like we can't go that way. We can't go like upstairs. Oh, wow. We didn't have that. I'm about to just run that way. You need to know how to go back. You could go down the stairs and outside. Like go to Peter's and nobody gets there.
Oh,
Cafeteria, and then you go.
No, you don't need, yeah, pass those out.
My parents told me to ask you.
Tell me. Oh, nobody's leaving yet. And, where's Kate's bringing him around?
Michael Tuttle. Good, Walt.
He's bringing him
How
around.
about Mike? Mike.